Hey students, I'm here to talk about section 1.5 and its greatest common factor, and it's also known as the GCF. So we kind of talked about common factors and we kind of blended in some greatest common factors, but we're going to really practice it fully in this lesson and make sure that you're comfortable with finding greatest common factors. Before we get into greatest common factors today, let's go over the bell work. So you should be on week 2, so it's Monday, and we are talking about these 3 problems right here. So first of all, number 1 should look very familiar. We had one of the problems that looked just like that from last week. So expanded form. So we're going to write this in expanded form. So we're going to go 10 times 10 times 10, and that's our expanded form. And then our standard form is we're going to actually multiply those and write out what it would be. So, or we could go, you know what, this is a 1 with 3 zeros. That's 1,000. So what I would like you to do is I would like you to try this one, 7 to the 4th power and 2 to the 5th power, on your own, and make sure that you answer put your answers into Go Formative if you're in Mr. Roberts or Mr. Kurt's class. Let's move on to number 2 now. It says add a parentheses to make this true. So we have 2 operations that are happening, and we want it to equal 27. So, you know, what would happen if I put the parentheses right here? Well, I would get 6. We'd have to do that first because it's order of operations. I'd get 63 minus 4. Well, that doesn't equal 27, does it? So we have to figure out what we can do, where we can put this parentheses to make it equal 27. Go ahead and give that a try, and let's move on to number 3. Compare the numbers. So we're using these symbols, greater than, or less than, or greater than. So we have to decide which number is bigger and which one is smaller. So let's take a look. I'm going to help you out a little bit. A lot of times when you're dealing with decimals, you can think of this as money. Well, I also think about saying the number the correct way. This is 1 and 22 hundredths. It's like saying I have $1 and 22 cents. This one right here is like saying I have $1 and 21 cents and barely a little more. So, would you rather have $1.22 or $1.21 and just a tiny bit more, but not enough to get to 22? So you can see which one is the biggest here. So we are going to say there. It's $1, or 1 and 22 hundredths is bigger than 1 and 212 thousandths. So I would like you to try this one on your own. Okay, so here are the notes. This is page number 35 in your journal. So we're looking down here in the bottom corner. So if you would please turn to page 35 in your journal. So hit pause right here. Make sure you're on page 35. And when you're there, hit play again. Okay, so everybody's on page 35. Now, let's discuss what some of this is on here. This stuff over here, each teacher is going to go over these with you. We are going to do this bottom problem right here. So right here, your teacher will go through this with you, and then I am going to go through this problem right here, and then we're going to practice a couple more over here. So first of all, let's look at this question. It says, Miguel wants to create party favors at his birthday party. He has 20 temporary tattoos and 16 pieces of candy. If each party bag is going to be identical and Miguel doesn't want anything left over, what is the greatest number of party bags he can make? So we're going to go through this question right now. So I'm going to use the cake method, and I'm going to start down here with 20. And just so we can kind of distinguish between the two different numbers, 16. So we have 20 and 16. Now, the first thing that you have to ask yourself when you're doing greatest common factor and using the cake method is what number can go into both of these numbers, 20 and 16, evenly? Well, a lot of you are already thinking 2. And again, does it matter if you come up with another number? Well, there are other numbers that go into 20 and 16. It doesn't matter where you start. So we're going to start off at 2 here. So just to distinguish, changing my color, we're going to start off with 2. Well, how many times does 2 go into 20? 10. How many times does 2 go into 16? 8. So there's my next layer of my cake. Now, I have 10 and 8. I do the very same thing. Is there a number I can take out of 10 and 8 evenly? Well, we could use 2 again. There's 2. So how many times does 2 go into 10? 5. And how many times does 2 go into 8? 4. Now, that's our next layer of our cake. We have a 5 and a 4. Are there any numbers that go into 5 and 4 evenly? No, there isn't. There's some that go into 4, but not 5. So it has to be both of them. So we know that we are done here. So that when I know that only one will go into it, I put the candles on the cake. These are our candles now. And we are left over with these 2 numbers on the outside. And that's like the icing on your cake. That's what we want. That's the best part of the cake, right? And that's the part we want to take off of the cake. So we got to multiply those 2 numbers together now. So 2 times 2 is 4. So our greatest common factor is 4. And that tells me what is the greatest number of party bags he can make is 4. If he only has 20 tattoos and 16 pieces of candy, he can only make 4 party bags that are going to be identical because it's the greatest common factor. So let's move on over here to this next page, and let's try a few of these on our own. And we'll start from the bottom and work our way up. So I'm going to start off with, let's just do a simple one. Let's do 12 and 15. Okay. Are there any numbers that go into 12 and 15? Yeah, 3. And you can use those rules of divisibility that we used on yesterday's lesson or last Thursday's lesson. That'll help you to get here. So how many times does 3 go into 12? Well, it goes 4 times. And how many times does 3 go into 15? 5 times. Okay, next layer of our cake. Are there any numbers that go into 4 and 5? No. So what are we left over with? We only have this 3 out here. Now, what happens when you only have one number? Well, that's it. Our greatest common factor is 3. So, pretty simple. Let's go over another one just to make sure that we're getting this. Let's try one that's a little bit harder. Let's try 24 and 48. All right, sorry about that. I got interrupted for a moment. Okay, so we're finding the greatest common factor of 24 and 48. So what numbers go into 24 and 48? Well, I always start off with, if it's bigger numbers, I always think, okay, what are some of the smaller numbers? Are these both even? Well, they're both even, so I know that 2 always will go into it. So I'm going to go 2, and that turns into 12, and that turns into 24. Okay, well, we have some options here. We could use 2 again. We could use 3. We could use 4. All of those numbers go into this. Also 6. But let's just stick with what we know, and we're going to go with 2 because we've already, that's an easy one. So we have 6 and 12. All right. Can we use 2 again? Yes, we can. So let's do it. And we are now way up on this cake. Well, it's a tall cake. And we are at 3 and 4. Are there any numbers that go into 3 and 4 evenly? No. So that lets us know we are done. We can put the candles on the cake. And we are now looking at the frosting on the outside. That's what we're taking off. And we're going to multiply those all 3 together. 2 times 2 times 2 is 8. So I know that my greatest common factor is 8. So hopefully you're getting the hang of this. And we've done it a couple of times. Let's actually do one more. Let's try 20 and let's see. How about 100? Ooh, a big 3-digit number there. So we're going to go 20 and 100. Well, what numbers can go into 20 and 100? Well, I know 5 does. That would turn that into 4. And 5 goes into 100 20 times. Or do we have any common factors between 4 and 20? 4. 4 does. Or 2. Let's do 2. 2 and then 10. Okay, do 2 and 10 have any factors? 2 again. Goes once and 5. All right, so we are now done. So, because I know I'm done because now I have a 1 on the top and a 5 on the top, and there's no common factors there. So I am going to go 5 times 2 times 2, which is 20. Now that might seem kind of odd to you that we have our greatest common factor is 20 when we already started out with 20. But that sometimes happens, and it's totally fine because sometimes the greatest common factor is one of the numbers that you're talking about. So it happens sometimes. Hopefully this has helped you a little bit. Let's move on to your assignment and maybe look at a couple problems and see how it goes. You may have noticed there is no practice for this assignment, and that's okay. We're going to use this assignment, and you can see on the back side of this paper is a place for you to work out your problems. We would really like you to use that because it's going to help you show your work. We want to see how you're working these out. But for my purposes here, because I didn't want it, because there was not a lot of space here, I'm just going to work a couple of the problems and show you what to do. So I am going to start out where it says start here. I'm going to go right here and do this problem. So on the back side of your paper, you're going to write down 10 and 15 and use the cake method to do this. All right, what numbers can go into 10 and 15? 5. So I'm going to go 5. It goes into 10 twice. And it goes into 15 3 times. Are there any numbers that go into 2 and to 3? No, so I'm going to put my candles on the top of the cake. Now, what do we have on the outside? What is the icing? We have the 5. And there's no other numbers to multiply it to, so we know that we have 5 as our greatest common factor. So I am going to get, what color here? Blue. And I'm going to fill in that. It tells me that I'm going down. That arrow goes down. So now I am working on this problem right here. So as you do this, it's a maze. You're going to do these problems and you will finish right here. So you're not having to do all of the problems on this page, but just the ones that the maze leads you through. Again, show your answers on the back side of the paper. And if you have questions, feel free to ask your teacher. Until next time, do your math.